If you're an ABAP developer, you know the world is changing, and it is changing fast. The move to S/4HANA and the cloud isn't just another upgrade. It is a total shift in how we think about and build solutions. So today, we're going to dive into the evolution of ABAP. We'll explore how modern syntax and a brand new mindset are turning that old legacy code into lightning-fast, clean, and totally future-proof applications. Let's get right into it.
First, we'll kick things off with the modern ABAP mindset, which is really the foundation for everything else. Then, we're going to get our hands dirty with two absolute game changers: inline declarations and constructor operators. But you know, with great power comes great responsibility. So next, we'll uncover a hidden performance trap that you absolutely need to know about. From there, we'll zoom out to talk about the philosophy of enhancing standard code. And finally, we'll tie it all together to map out your path to writing clean, modern ABAP.
For years, let's be honest, the motto in the ABAP world was kind of, if it ain't broke, don't fix it, right? But with S/4HANA and the SAP Business Technology Platform, that's all out the window. Modern development isn't a nice-to-have anymore. It's a core requirement. It's no longer just about getting the code to work. It's about building solutions that are sustainable, scalable, and ready for the cloud, all while taking full advantage of the power of the HANA database. This isn't just a friendly suggestion. This stuff directly impacts your performance and the long-term health of your system.
And this right here, this slide just says it all. I mean, look at the difference. On the left, you've got the old way, verbose, separate lines for everything, declaring the data, selecting it, looping through it. But on the right, the modern way does the exact same thing in 2 lines. It lets us focus on what we want to do, not the boring details of how we have to do it. This isn't just about typing less. It's a huge shift towards clarity. So let's break down the magic that makes this happen.
Okay, so the first pillar of this beautiful new simplicity is the inline declaration. The idea behind it is just brilliantly simple. Why should you have to manually type out a variable's definition when the compiler already knows exactly what kind of data it's about to receive? It's all about letting the system do that heavy lifting for you. Let's see how this actually works.
So here's the key. An inline declaration creates your variable at the exact moment you first need it. When you use that data syntax, you're pretty much telling the compiler, hey, see this data I'm about to give you? Just create a variable that's the perfect size and shape to hold it. This just vaporizes all that boilerplate definition code you used to have to put at the top of every program.
All right, let's do some rapid-fire examples. You'll see how quick this is. The old way, you declare a variable on one line, then you assign a value on the next, blah. With an inline declaration, you just write data LV variable equals some value. Boom, one line. It's clean, it's concise, and you know exactly what's going on.
Now for a real classic, looping through an internal table. We all used to have to explicitly declare a work area or a field symbol that had the exact same structure as the table. Now, you just write loop at LTITab into data ls work area. The compiler creates that work area for you, on the fly, perfectly typed. No more guesswork.
And it's the same deal for reading a single line from a table. That old 2-step process of declaring a variable and then reading into it becomes this beautiful, single, super readable statement. Read table LTITab into data ls work area. You immediately see the intent of the code without having to scroll all the way back up to find out what that variable was.
And here's where it gets really powerful. Instead of manually defining a complex data type, then defining a table based on that type, you can now just select data directly into an inline declared table. A statement like select into table at data LT flights creates that internal table, LT flights, right then and there with the perfect structure based on whatever you put in your select list. It's a game changer.
So, inline declarations are all about making our code simpler. Constructor operators, on the other hand, are about making it smarter and way more expressive. This is a real shift in thinking, from just writing a list of step-by-step instructions to building these powerful single-line expressions that create and manipulate data all at once. Let's meet the big 3 operators that make this happen. First, new lets you create instances of objects or data objects instantly. No separate declaration needed. Next is value, which lets you build the entire contents of an internal table right inside an expression. And then there's reduce, which is an absolute powerhouse for doing calculations across a whole table, like summing up values, all without writing a single manual loop.
Just look at this comparison. On the left, you've got your standard everyday loop to calculate a total. It works, sure, but it takes 3 lines and a helper variable. Now look at the right. The reduce operator does the exact same thing in a single, elegant expression. It practically reads like plain English. Reduce this table of numbers into one final value by adding them all up.
That is the essence of coding smarter.
Okay, so far, modern ABAP seems like a total slam dunk. It's shorter, it's more readable, it's more powerful. What's not to love? Well, as it turns out, all that convenience can sometimes hide a really nasty trap, especially when it comes to performance. And this brings us to a really critical question. Given how easy and clean these inline declarations are, especially for creating internal tables, is there any reason not to just use them all the time for everything? The answer, and this might surprise you, is a definite yes. And oh boy, this chart tells the whole story. Just look at these numbers. This is from a test, doing a nested loop over a pretty big table. The table we created using that convenient inline declaration took over 147,000 milliseconds. That's over 2 minutes to process. The exact same logic, but this time using an explicitly declared sorted table, took just 81 milliseconds. That's not a small difference. That is thousands of times faster. It's night and day.
So what on earth is going on here? Well, the why is actually pretty simple. When you use that slick select into table at data syntax, ABAP always creates a standard table. And standard tables, by definition, have no key and are searched linearly. That means for every single row in your outer loop, the system has to read through that entire inner table from the very beginning to find a match. For large data sets, this is an absolute performance killer. The solution is clear. If you are going to be reading a large table inside a loop, you must explicitly declare it as a sorted or hashed table. That's how you get those super fast key-based lookups.
All right, let's pull back from the nitty-gritty syntax for a second and talk about the core philosophy that drives all modern SAP development. For decades, the biggest headache for developers was customizing standard SAP code without creating a total nightmare for the next system upgrade. The modern answer to this problem is simple and absolute. Enhance, don't modify.
This quote really just sums up the whole idea perfectly. Every single time you go in and directly change a standard SAP object, you're basically creating a time bomb for your future self. The enhancement framework lets us add our logic or even replace SAP's logic while keeping a clean wall between their code and our code. This makes upgrades infinitely smoother and our systems way more stable.
You know, it's been a long road to get here. We started way back with core modifications, which were super risky and required an access key. Then came user exits and customer exits, which were a bit safer but still really rigid. Then business add-ins, or baddies, brought object-oriented concepts into the picture, which was a huge step. And finally, the modern enhancement framework came along and basically unified all these older ideas into one powerful, flexible toolkit that can handle just about any scenario you throw at it.
Within this framework, you've got two main explicit options. Think of an enhancement point as a little hook where SAP says, hey, if you want, you can add some of your own code right here. It doesn't change their code, it just adds to it. An enhancement section is different. That's where SAP wraps a whole block of their code and says, look, if you really need to, you can just replace this entire block with your own logic. Knowing when to add versus when to replace is totally key.
Okay, so we've covered new syntax, we've looked at performance traps, and we've talked about the enhancement philosophy. Let's bring it all home. Becoming a modern developer isn't just about memorizing a few new keywords. It's about adopting a whole new mindset, one that's laser-focused on creating clean, efficient, and maintainable code.
So here are the core principles to guide you on your way. First, use that modern syntax to write code that's concise and clearly says what it's trying to do. Second, always think about performance. Inline declarations are awesome, but remember, for big tables inside loops, a sorted or hash table is your best friend. Third, make the enhancement framework your go-to. Always try to enhance before you even think about modifying. And finally, never forget that code is read way more often than it's written. Focus on clarity and giving things meaningful names.
Look, this transition from classical to modern ABAP is a journey, for sure, but it's one that completely future-proofs your skills and your company's systems. The tools are there, the path is clear, so really, the only question left to ask is, what's the first piece of old code you're going to go modernize?